this video I want to go over the precise definition of a limit. Before we get started, let's go over three terms. This symbol right here means exists. So we know that there's at least one out there with that, but that'll be more handy later where we say at least one. Actually, probably not even in calculus. I can't remember for sure if it'll be in this playlist at all. Anyways, this right here is delta. It's the Greek letter delta, and it's a small positive number. So anytime we just need a small positive number, we use delta to denote that. And we have one more symbol for a small positive number, and that is epsilon. So epsilon is a small positive number. And there's no telling if epsilon is greater than delta, or if delta is greater than epsilon, or if they're equal. It'll depend on the context that you're using it in. So the definition of the limit says that the limit as x approaches a of f of x equals L if, so all these conditions need to be true. For every epsilon greater than 0, there exists a delta greater than 0, such that the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is less than delta, and x is not equal to a. So it sounds complicated, and the one below that, it's equivalent to, and it sounds just about as complicated. So let's draw a graph, and hopefully this will make a little bit more sense. Let's say we have this graph down here. We'll draw it in blue. So we have this line. I'll actually make it dip there. That'll make it easier to draw. We'll call this part on the line here. We're just going to pick the lowest point on the line. And we could have picked any point, but it'll be easier to do around the dip. We'll call that L. And the part directly below it will be A. So this limit definition says that if we pick any number epsilon, so we have a really small number epsilon, and we're getting it within, we're picking a point within epsilon units of L. So epsilon could be there or here. So we have some kind of number that is inside these two lines. So we are this close to L. It says that there exists a delta that's within this area that's not on point A. So we'll just call this right here our point. Our theorem says that there exists some kind of delta. It could be bigger than epsilon in some cases, it could be smaller. In this case, I think it's a little bit smaller the way I have that drawn. It says there's a delta within this area right here. So we have this delta area, and we also have a point. We'll do it in teal. We'll say this is our delta. So no matter how close we pick this epsilon, no matter how small we make it, and we can squeeze this as much as we want, we can always find a delta that's within that many places. So we can always find a delta close to A that does not equal A.